In West Philadelphia, born and raised, on the playground is where I spent most of my days. Chilling out, maxing. Oh, we're recording? Hi, so you're here to learn about surface area. You've come to the right place. Surface area is when you get the area of all of the faces of a three-dimensional figure. Now, here's the question you have to ask yourself. What's a face? On a prism, you can just count the faces. What's a common example? Dice. How many faces are there on dice? Well, what you'll notice if you rotate it all the way around and touch all of the flat, solid surfaces is that there are, in fact, 6 faces on a dice. So, when you are getting surface area, you would need to get the area of all of the faces. So if it was this shape, a cube, you would get the area of all of the sides, and then you would add them up. What lesson does this remind you of? If you said composite figures, you would be correct. Surface area is similar to the lesson on composite figures because you are adding the areas together. The key difference, of course, is that for composite figures, all of the shapes were two-dimensional, but surface area is measuring three-dimensional shapes. What does a three-dimensional shape look like? If you take a look here, I'm going to take these cubes and I'm going to build something. What does this look like to you? It looks like a rectangle, right? We have a length and a width. It's 2 by 3. And we know the formula for area of a rectangle is length times width. So the area of this would be 6 cubic inches. Now, if we wanted to make it a three-dimensional figure, that would mean instead of just having a length and a width, we would need to add a dimension called height. Okay? And this is where you can think of this shape as being stacked or extended on itself. Let's see what that would look like. Now if you look, what I've done is I've taken that 2 by 3, and what I've done is I've added a height now. Okay, so that 2 by 3, it's 2 by 3, 2 by 3, 2 by 3, and 2 by 3. If I want to get the surface area, then what I need to do is I need to get the area of all of the faces. So it's basically just 6 problems, okay, because there's 6 faces, right? There's a front, there's a back, there's a top, there's a bottom, and then there's 2 sides. So first let's get the area of the front. 4 by 3. What's the area of the front? 4 by 3 is 12. The good news is, if the front is 4 by 3, that also means if I flip it around, the back is also 4 by 3. So there's another 12. Now, what about the top? The top we already knew from before. 2 by 3. So the top is 6. The bottom is 6. And now we have the 2 sides. If I turn it so that you can see the sides are 4 by 2. So 8 and 8. So now if I want to know the surface area of the entire three-dimensional rectangular prism, I would need to add up all of those different areas. So we had 12 plus 12 plus 6 plus 6 plus 8 plus 8. Let's see what that looks like written all out. So these were the 6 area problems that we did. The top and the bottom were the same, 2 times 3. The front and the back were the same, 3 times 4. And the 2 sides were the same, 2 times 4. So these were all 6 of my different faces. So I added them up, 6 plus 6 plus 12 plus 12 plus 8 plus 8. And I got 52 square inches. Okay, this is how you do rectangular prisms Because they have 6 faces and the opposite faces are always the same. In fact, as long as you understand the concept behind this, I'm going to show you a quicker way to do the next one. Take a minute and add this to your notebook. The formula for surface area of a rectangular prism is 2 length times width plus 2 length times height plus 2 width times height. I want you to take a second and think. Why are there 2's here? Now I'll give you a clue if you haven't figured it out. What's 2 plus 2 plus 2? Have you figured it out yet? Good. Because there's 6 faces. This is the front and the back, the top and the bottom, and the 2 sides. So those are the same 6 faces that we had on the other rectangle. Now let's take a look at an actual problem to apply this formula to. Here's a rectangular prism with measurements of 5 meters, 8 meters, and 8 meters. So the first thing that you should do if you want to draw this into your notebook is just draw a rectangle, and then draw another rectangle that goes into the first one, and then just connect the corners. Oh, I missed a corner. Here we go. There we go. And now the good news is we can use our formula to solve this problem very quickly. Take a look. So I just took my formula, 2 length times width plus 2 length times height plus 2 width times height, and I substituted in. Okay? If you remember, this is your length. This is your width. Okay? So this is the length times the width. That's the top and the bottom. If you want to write yourself a little note, you can. This is the top and the bottom. Then the length and the height, that's the front and the back. Okay? This is the front and the back. And then 2 width times height, those are the 2 sides. Okay? The sides are right here and right here. Okay? These are side and side. So it's 4 lines of work, by the way. So it's 2 times 8 times 8, so that's 128. 2 times 8 times 5 is 80. And I know it's 80 again. Then I add them all up. And for my final answer, I'll get 288 square meters. And it's square meters because we're working with area. The top and bottom, plus the front and the back, plus the 2 sides, gives me all 6 faces, which gives me 288. These 4 steps, okay, is what I'm expecting to see on your assignment today. Okay, so this is how you do surface area of a rectangular prism. Good luck, and let me know if you have any questions.